All right, you guys, so here's section 6.5. Do your best, follow along, pause the video anytime you want, try a few examples, however works best for you. So we determined whether quadrilaterals were parallelograms under rectangles. So now we're going to look at rhombi, which is the plural of rhombus, and squares today, okay? So a rhombus is a parallelogram with four congruent sides. Remember, rectangle had four right angles. And a square has got four congruent sides and four right angles. So, a couple theorems that go with a rhombus. If a parallelogram is a rhombus, then the diagonals are perpendicular. So they intersect to form a right angle. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So 5 and 6 are congruent, 7, 8 are congruent, 3 and 4, 1 and 2, etc. So we're going to utilize that information here in the next couple slides. Here's a theorem here's a proof of this. So if we're given that it's a rhombus, why are the diagonals perpendicular? If you want to read through this, this is in the book. But here's the idea, you guys. AB and BC are congruent because a rhombus has four congruent sides. These segments AP and PC are congruent because the diagonals of a parallelogram bisect each other. And of course, BP is congruent to itself. It's a shared side, so by side, 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 the triangles are congruent, which means the corresponding parts are. So these two angles here, BPA and BPC, would have to be congruent. All right, well, think about that for a second. If I have congruent angles that are also a linear pair, well, then they have to be right angles. And if they're right angles, that's the definition of perpendicular. So an example of what a proof might look like for some of these. A lot of them involve triangles. Okay? So the diagonals of rhombus XY or WXYZ intersect at V. If the measure of WZX is 39.5, find ZYX. So WZX is this 39.5 right here. And because in a rhombus the diagonals bisect each other, this other one's also 39.5, making that whole angle 79 degrees if you add them together. Okay, well ZYX is this one over here, and in a parallelogram, the consecutive angles are supplementary. So if I subtract that from 180, I should get my solution. And you're going to see us walk through that in a second. So I have to recognize the consecutive angles have to be supplementary. I knew that that one angle on the left side was 79, so I can replace it and subtract, sure enough, 101 degrees. Okay? Now they've given me some information about a couple of sides. One of them is 8x minus 5, one 6x plus 3, but because it's a rhombus, you guys, the sides have to all be congruent. So I'm going to set those two expressions equal to each other and solve for x. And as you look at the right there, that's all they're asking me to do. I don't need to plug it back in. So go ahead and set those expressions equal to each other. Solve for x. Okay, so think about this one on your own. Pause the video, see if you can come up with what it needs to be. All right, knowing it's a rhombus, and knowing that top angle is 126, they want me to find CDB, that little one on the other side. Well, in a parallelogram, the opposite sides or angles are congruent, so that entire angle would be 126. I also know the diagonals bisect each other, so that one would be half of 126, or 63, you guys. Okay? All right, well, I've already kind of worked this one out for you. Let's take a look at why. I think you guys are pretty comfortable with this. They give me two sides of a rhombus. I know they all have to be congruent because that's the definition of a rhombus. I set them equal to each other. I solve for x. Good to go. All right, so if I look at a Venn diagram here and I think of this whole box as any parallelogram, so this is a parallelogram that's not a rhombus or a rectangle or a square. None of the sides are congruent. None of the angles are right angles. Okay? These are rectangles that aren't rhombi. So they've got right angles, but they don't have congruent sides. These are rhombi that aren't rectangles. All the sides are congruent, but the angles aren't right angles. And of course, the square satisfies both. Okay? All the sides are congruent, all the rectangles are, or all of the angles are right angles. Okay? A couple theorems that'll help me prove that something's a rhombus. In a parallelogram, I must first know it's a parallelogram. If I know that the diagonals are perpendicular, then it must be a rhombus. So show it's a parallelogram, show the diagonals are perpendicular, you can conclude it's a rhombus. This one, if the diagonals bisect a pair of opposite angles, so if you could show me 1 and 2 are congruent and 3 and 4 are congruent, And you already know it's a parallelogram, must be a rhombus, okay? If one pair of consecutive sides of a parallelogram are congruent, it must be a rhombus. So you must show me the consecutive sides are congruent and that it's a parallelogram. And of course, we already talked about this. If it's a rectangle and a rhombus, it must be a square. Okay, so a paragraph proof. They tell me 1 and 2 are congruent and 2 and 6 are congruent to begin with. I want to prove that this is a rhombus. Okay? Well, I know that the opposite sides are parallel. And if I know that, then angle 1 is congruent to angle 5 because the alternate interior angles are congruent. And then if we keep going with that, you guys, if 1's congruent to 5, well, I knew I was given 1 congruent to 2 and 2 congruent to 6, so by transitive 1 is congruent to 6. And if 1 is congruent to 6 and 1 is congruent to 5, by substitution or transitive 5 is congruent to 6, then I've shown that in this parallelogram, a diagonal bisects a pair of opposite angles. Well, that was one of the theorems we could use to prove that this is a rhombus, and so we're good to go. Okay, is there enough information to prove that this is a rhombus? So I'm given it's a parallelogram, check. And I'm given some sides congruence. Well, we had a theorem that said it in a parallelogram, if the consecutive sides are congruent, which is what we have, then we do have a rhombus. And so yes, I think we do have enough information here. Okay? Hector is measuring the boundary of a new garden. He wants the garden to be a square. He has set each of the corner stakes 6 feet apart. Okay, so if he's made sure that all of the sides are 6, he's guaranteed that it's a rhombus. What does Hector need to know to make sure that it's a square? Well, he has to also show that it's a rectangle. And we've got a couple ways of doing that. One is to show the diagonals are congruent. So he could measure the diagonals and make sure they were the same length. Or he could make sure that he has a right angle in there, and he would be good to go either way. The book's definition or the description has him measure the diagonals and make sure that they're congruent. So we already knew it was a rhombus because the sides were all congruent. We then had to show that it was a rectangle as well. Okay? So what about here, you guys? Sachin has a shape he knows to be a parallelogram, so that's good. That takes care of a lot of what we had to prove. And he knows that all 4 sides are congruent. Which information does he need to know to determine whether it's a square? So pause the video, think about that for a second. All right, all 4 sides congruent. I know it's a rhombus. So to prove that it's also a rectangle, we had said on the previous slide we could show that the diagonals were congruent. I think if we did that, we'd prove it's a rectangle. We know it's a rhombus, so then it would have to be a square. All right, determine whether this is a rectangle, a rhombus, or a square. So in coordinate geometry, guys, we have a couple of tools. We have the distance formula, we have the midpoint formula, and we have the slope formula. So in terms of rectangle, rhombus, and square, if we already know that it's a parallelogram, which is a huge piece of information for us, to then narrow it down, we're going to use diagonals again. So if I show that the diagonals are congruent using the distance formula, measuring the lengths, then I can say it's a rectangle. If I can show you the diagonals are perpendicular using slope and showing that they're opposite reciprocals, then I can show you it's a rhombus. Well, if both of those are true, it's a rectangle and a rhombus, so then therefore it would be a square. And so that's what they're going to do. They're going to go ahead and plot it first. Kind of looks like a square, right? I don't know that for sure until I actually do some math, though. So we're going to measure, we're going to start by determining, using the distance formula, you guys, you should have that, the length of the diagonal. So the first diagonal is the square root of 34. The second diagonal is also the square root of 34. So since the diagonals are congruent, it's got to be a rectangle. Now we're going to measure the slope of the diagonals. The first one's negative 5/3. Now the opposite reciprocal of that would be 3/5. So if the other one is 3/5, which it is, then the diagonals are perpendicular because those slopes are opposite reciprocals, which makes it a rhombus. And if it's a rectangle and a rhombus, then it has to be a square. So I can conclude that it's all 3 of those. Okay? So let's look at some of the math on our own here. Okay? So we've got this shape that we're going to put on a coordinate plane. They tell us it's a parallelogram, so I don't have to go into detail there. I'm going to start by trying to show if it's a rectangle. Okay, so the measure of EG, okay, the x coordinates 0 and -1 are 1 apart. The y coordinates 3 and -2 are 5 apart. So 1 squared plus 5 squared, square root of 26 for that length. FH, the other diagonal, from -3 to 2 is 5 apart. From 0 to 1 is 1 apart. 5 squared plus 1 squared, square root of 26. Diagonals are congruent. That makes it a rectangle. Now I'm going to measure the slopes of those same diagonals. So for EG, change in y's, -2 minus 3 is -5. 0 minus -1, the change in x's is 1. So I get -5 for the slope of that one. FH, 1 minus 0 is 1. That's the change in y's. Change in x's, 2 minus -3 is 5. These two are opposite reciprocals, so now I know it's a rhombus. Well, if it's a rectangle and a rhombus, it must also be a square. So I can choose all three. Okay, there's your assignment. Good luck.